Welcome back to our second exercise in critical path method calculation. Today, we are going to see one more level complication being introduced into our calculation. For example, here I'm assuming some kind of a construction work. For each and every activity, instead of just giving us the days or the duration, we are given the best case, the worst case, and the mean value, which is called as the pessimistic value, which is the worst case, optimistic value, which is the best case, and most likely, which is the mean. And of course, we have the predecessor. Now, while we are taking this approach, please do not go for the pessimistic alone, because that is the worst case situation, and our schedule will be totally haywired if we are going with a pessimistic approach. How about taking only the optimistic value? There is a possibility that when we face a risk, we won't be having any cushion to face the risk in a comfortable manner. So optimistic alone may not help as well. Mean, probably it might work. So what we are trying to do is identify the PERT calculation first. PERT formula, we are all familiar with this. Pessimistic plus optimistic plus 4 times most likely divided by 6. Based on statistical analysis, we are going with this PERT analysis. And when we are replacing the P value, O value, and ML value in this formula, we get this answer. For example, for A, activity A, pessimistic is 16 days, optimistic is 6 days, most likely is 11 days. But the PERT value is 11 days. More or less, it will be aligning with the most likely value. You're right. That's why I said if we are taking only the mean value, will it work? Sometimes, yes. For example, look at the activity E or activity F. I've given some hypothetical numbers over here just to demonstrate that, or not EF probably, right? Or even H. If you look at F and H, the mean value or the most likely value is slightly different from the PERT value, because hypothetically I have taken the values as I was mentioning earlier, just to show you that there may be a possibility of a different number, right? So now we have the PERT value along with this. So the PERT can be used safely as our duration. This is what we call it as a 3-point estimate. Since we have the duration right now, and we do have the predecessor, and we do have the activity, we can straight away start plotting this into our network diagram. This is what we are getting when we are plotting the earlier numbers. So if you just go back to the earlier ones, E and F, there is E, F, and G. There are two activities which are the predecessors. So similarly, we are able to see this as well. Right. Now, as we already know, activity name must be written in the center of the box. Top center must be the duration. So we have already plotted this. Unlike the earlier exercise we saw, there is a slight difference in this. I'm sure you would have observed it. You're right. There are 2 starting activities and 2 ending activities. Nodes, if you look at the nodes, A and B starts the project. G and F concludes the project. So yes, we are able to see 2 activities starting and 2 activities completing. So let's look at how to work out your critical path in this kind of a diagram. So we're going to start with the forward pass, and we all know the forward pass usually starts with a 0. So A and B starts with a 0, and A, since it is 11 days, the completion date is 11th as well. Now, since D and C can start after A, D and C, we are taking the early start as 11 days. D concludes on the 16th, C concludes on the 17th, right? Now, we won't be able to, if you just look at this, Since there is a dependency of B, if you want to work out F and E, that is the reason we can't work out until we complete the calculation for B. What I mean by this is B and C must complete before we can start F and E. That's a dependency we are able to see. Now we know C is finishing on the 17th. Since we don't know when B is finishing, we won't be able to work out F and E calculation. So we need to then complete B. So B starts on the 0th day, and since it is 13 days, we are finishing it on the 13th. Now 13 and 17, right? B and C, if we look at it, it is 13 and 17. Obviously, when we are walking forward, we need to take the maximum value. So F is 17, and since it is 9 days, completion is 26. H is also 26 because we are just going to carry over that number. 26 plus 11 is 37, right? We can't conclude the project until we finish with G. And for us to start with G, we need to know E values as well. So we are moving on with E. 17. 17 plus 8 is 25. Since it is 25, G also starts on the 25th. 25 plus 6 is 31. So if you look at it, H has a 37 as a conclusion time. G can finish on the 31st. And we all know while walking forward, we need to take the maximum value. So the project completion time is 37, right? So when two activities are concluding, you need to take the maximum value of the early finish in order to see when the project is completing. So that gives us an idea about the forward pass. Again, I'm repeating, forward pass is, it starts on the 0th day. 0 plus duration will be the early finish. For the subsequent activities, when you have more than one activity as a predecessor, in those cases, you need to take the maximum value of the predecessor activities, and we have to start working on this. I'm sure forward pass is clear now. Usually forward pass is very easier. The challenge would be in the backward pass. So let's start with the backward pass now. As the name specifies, we need to walk backwards, which means we have to start from the end, right? Since we know the project is finishing on the 37th, H late finish is 37, G late finish is 37. You can see below on the left-hand side, I have given the legend to say where you have to write the early start, early finish, late start, and late finish so that we can be more easy while we are interpreting this diagram. Now, since 37 is the conclusion time, H and G has a late finish of 37. So G, since it is 37 minus 6, it is 31. And E and D, because there are two arrows, right? So E and D can be taken as 31. So D, since it's 31, minus 5 is 26. Right, now we can't work out A until we finish C. So in order for that, we need to go back to H. Right, so when you look at E, 31 minus 8 is 23, right? Now I'm going back to H. 37 minus 11 is 26, and 26 goes in for F as a late finish. So 26 minus 9 will be 17. And while walking backwards, we need to take the minimum value. We have already spoken about this logic, why we need to take the minimum value. The simple logic is there are two dependencies, which means B and C must complete before we start with F and E. F is starting on the 17th, E is starting on the 23rd. So ideally, B and C should have been completed by the 17th. Only if it is completing on the 17th, we will be able to start F by the 17th. That is the simple logic we are looking at. So 17 goes in for B and C. B, 17 minus 13 is 4. For C, 13 minus 6 is 11. So now we have C and D values, so we can comfortably start calculating A. So which means goes back to 11. 11 minus 11 is 0. When we have two activities starting the project, if one project activity has a 0 as a start, late start, we are comfortable. Because as long as there is one critical path, which means the project is a safer project. So now I'm sure you're clear when you have two starting and two ending nodes, how to calculate your early start and early finish, right? Right. If you have any questions, you can post it up in the comment section. We will take it up and probably I can explain it later for that. Now we are going to work out the float. Float is nothing but late start minus early start or late finish minus early finish. Simple logic is here. This minus this or this minus this. And we usually write it in this section. As I already given it in the legend, you can have a look at it. Pretty simple to do this calculation. So when you talk about A, 0 plus 0 minus 0 is 0. 11 minus 11 is also 0. Both must be the same number. If not, we have made some error in our calculation. Have a look at the calculation once again. B is 4 because 17 minus 13. C is 0. D is 15. F is 0. E is 6, H 0, G 6. So the way how we calculate the entire critical path is based on the float values. So if you are asked, what are the critical activities in this project, look up for all the zero activities, zero float activities. Those are called as the critical activity. For example, A, C, F, and H has a zero float. So it is called as a critical activity. Whereas B, E, D, G, all those are called as a non-critical activity. So when we draw a path, something like this, A, C, F, G, end is going to be our critical path. So critical path is the longest path in a network diagram, which means if you add up all the different paths, A, C, F, and H will have the maximum number, which is 37. So that is the longest path in a network diagram. It is also taken as the minimum duration needed to complete the project. Any shorter than 37 days, we wouldn't be able to complete this project. So 37 is taken as the minimum duration needed to complete the project. If I give 35 days or 36 days, we won't be able to complete this project because the minimum time we need to complete this project is 37. And how did we work that out? When we add all the paths, the longest path will be taken as our critical path. Hope this makes our understanding clear. If you have any question, please post it in the comment section. We will take it up and we'll answer that later. I'll come back again with the next calculation. Until then, bye-bye.